Elizabeth Campbell from the office. Elizabeth Campbell.
Didn't realize there were locked. Didn't even. Well, we're out at 2:25, so, but, I mean, you can shoot right.
What's all the same thing? And then
Alright, hey, let's continue on with our notes that we started yesterday. We got to one problem yesterday where I handed it out and I asked you to solve it on your own, and then we never really came back to it. And I wanted to start that one problem today. So here's our goal. Okay, our goal are to do a couple examples today. I got about 4 or 5 that I want to do today in class. Pretty quick. Obviously, the first one we started yesterday, so that was kind of a cheat. But really, the rest of the problems, the rest of those are ones I want to like look at them, work on your own. There's a couple tough ones in there because I do want to give you some challenge ones, some easy ones, kind of a mixed bag. And then once we're done with that, you will get homework today. The homework that I'm going to hand you will be due this Friday because I think it's straightforward. You guys said that yesterday the problems I gave you, at least the later classes said they were pretty easy. Like the examples I put on the board here, there's like maybe one that was a challenge. The homework is actually really simple. Like the problems I'm picking hard problems so that you guys are like way over prepared for the homework that you're going to have. Okay? All right. So this is the problem we had yesterday. If you don't remember, this is the one I did one of these in class where I gave you like two of the angles and I gave you some stipulations. So it was something like this. It was, you know, I gave you angle 5 and 7, and I told you what they are in algebra-like terms, right? And what you have to do is you have to solve for the variable, so you had to find x, and then you had to find the remaining angles using that x. And I think this was the problem, correct, that we did in class? Okay, now again, if you look at the picture, 5 and 7, 5 is here, 7 is here, these angles are equal to each other. I know that from looking at the picture, because what type of angles are those called? Corresponding. That's our postulate, right? That those two angles are equal. So what I did yesterday is I set these equal to each other. And what we had to do is we had to solve for x. I think x turned out to be a 25 or something like that. And then you took your 25 and you plugged it back in here to these. You can plug into one or the other. And when I plug in 25, you figure out the angles were 40s. Okay, and then you can figure out all the rest angles in the picture, because if those are 40s, then all these angles can start hopscotching around. Like they can go vertical, they can do alternate interior, or they can go corresponding. Corresponding to there, because I mean that's inside, that's outside, and then it goes vertical. So we knew that 6 was 40. That can go corresponding to here, or alternate interior, whatever you want to think of. And then now these have to add up to be 180 because it makes a straight line. So this has to be 140. Right? So you can like hopscotch around using your little properties, alternate interior, alternate exterior, that type of thing. In fact, these are alternate exteriors, like hopscotched all the way across the picture, that type of thing. So that was the one that we did yesterday. Now, your problem, all I did was slightly modify the numbers. So here's what I gave you, right? I gave you 6 and 8, and they were just different numbers, right? This is the problem that you had right before we left, correct? Okay, and the goal was to try to see if you could figure it out. Now I'm going to label the picture here, and I don't know if we even got to talk about this one yesterday. So 4, this is a y minus 25, and the 8 was a 4y. Okay, so let's start with this one. This would be our kind of our quick review into this. So here's the thing: when you look at the picture, okay, they give me 6 and 8. They're variables, they're algebra terms. Are those angles equal to each other? No. Okay, I think I heard a yes. They're not. Now, why are they not? Yeah, they have to add to make 180. Now, the reason why we know that is because this angle 6. Now, if I actually simplify this, distributing the 4 through, this actually turns out to be a 4y minus 100, right, when I distribute the 4 through. So that's angle 6. Well, this can do, vertical to here if you want, or it can just do a corresponding to here, but it's definitely not this angle, okay, because it corresponded to here. That's outside, this is inside. Hold on. Go back. Alright. But these two angles have to add to make 180, like you guys were saying. So that's what you need to realize. You need to kind of pick things apart, maybe label the picture. So now that I know that those should add up to be 180, that's what I'm going to do. So 4y plus the 4y minus 100 should equal 180. They're supplementary to each other. And they're side by side, they're adjacent. So this should add up to be 8y minus 100 equals 180. You would add the 100 across, making that 280 over here. And when I divide by 8, I believe you get something like 35 or something like that. Okay. So the idea is that if that's 35, what you can do is you can plug that back in. You can plug the 35 in here. 35 minus 25 is 10. 10 times 4 is 40. In fact, it's kind of a joke problem. It's the same. That was 40. That means this is 40. This has to be 140. It's the same problem. I just changed the variables. Forgot to be the same. Alright. Any questions with how I did that problem? And again, if you actually plug the 35 down here, it actually does turn out to be 140. So that's the way you can do it. And then 5 and 7 would be the same as 6 because we did that one before. Alright, any questions with the example we did yesterday? That was the last one right before I flicked the bell on. Okay, let's jump in. Let's do a couple more just to kind of get our brain flowing here. Let's get a different picture, some different items here. I think I'm going to stick with this idea of algebra problems because it takes a little more thought. Okay, all right, so new picture. So here we go. So obviously on this picture we have parallel lines here and here. We have 8 different angles. Now here's the stipulation. Again, we want to find the measure of each angle, 1 through 8. But here's what they give. Angle number 1 is an x plus 25. Angle number 1. And angle number 7 is a 4x plus 13. Okay. Alright, so you can go ahead. I want to see if you and your little group, your little pod that you're in, can see if they can figure out each of these angles. Take 3 or 4 minutes. Let's see if you guys can figure out how are these angles related, maybe hopscotch them around a little bit, use some properties. Let's see if you can figure it out. I'll give you about 3 or 4 minutes. Talk amongst your group. If you need to move to a new group, that's fine. Whatever you need to do.
Whoa, that's great.
All right.
Sorry, 29.
All around. Okay, Matt, maybe another 2 minutes here. If you need it. Remember, you're trying to find each angle. Now, if you're not quite sure, that's fine. But maybe we can get the setup correct, and then maybe you can figure it out from there. Okay. Here's a question. Does anyone need more time to try to solve that? Okay. All right. So I'm just going to go around the room, kind of get your ideas what you think about these angles. We'll start up here. I'll kind of work my way around the room. Let me label some of these. So x here is, or number 1 is an x plus 25. 7 is a 4x plus 13. All right, so girls up here, what do you guys think? How are these angles related? Is there a relationship? They're equal. Okay, yeah. Here's the idea. These angles are actually the same. Now, why? Hey, yeah. She's really good at that one. I'll give you that. Hanson. You know that one pretty well. They're alternate exterior, right? They're on the outsides of the picture. They're alternating sides of the transversal. They have to be the same. So if they're equal, you set them equal to each other, like this. And once you have them equal to each other, you can solve, right? So I'm going to move this 1x across. I'm going to have to subtract it. So 4x minus the 1x. I'm going to move the 13 over here, so that subtracts. And what I'm going to get is 12 equals a 3x, and then you can solve. You can divide by 3, and your x has to be a 4. Now, why that's important? I have to plug that back in. If I plug in 4 back in, 4 plugged in here, 4 plus 25, that's a 29. So both of these angles have to be 29. That's what it's basically saying. And so now that we know that's 29, now we can find what the rest of the angles are. Because like angle 3 would have to be 29 because it's vertical. Alternate interior to here, or vertical, however you want to think of it, or corresponding, that type of thing. And then the other angles are the ones that have to add with the 29 to make 180. Like 8 plus 29 here. This has to make 180, so this would have to be like 151. So there you go. That's how it's done. I mean, it's meant to be real quick. Okay. So, do we understand like the basics here? Like what we're going to do? We're going to do a couple more of these. Okay, but that was the idea. Was like the first thing you had to realize, like the relationship. Maybe there was none. Maybe they just had to make 180, but these are actually the same. Okay. All right. So I'm going to call on one of the next groups now for this next one. So all right, next problem here. Okay, I think if this isn't one of the easy ones, I'm gonna have to switch up the slide here. This is not. Okay, hold on. Ignore this one for right now. We'll come back. That's not the easy one. This one. All right, here we go. All right, so we have angles, 10 through 17 here. We have parallel lines. All right, here we go. Find the measure of each angle, same as before. X, or I should say angle 12 is an x plus 51, and angle 14 is a 3x plus 29. Okay, so those are my two angles this time. Same exact idea. I want to see if you can figure out what each of the angles are. And I'm going to try to pick on one of my other groups. So these two groups are good. That's fine. I'm going to pick on one of the back groups. Okay, got about 3 or 4 minutes. Then we're going to go back to those ones I skipped. This is like kind of the tough ones. Remember, the first step you should do is figure out what the relationship is. Are they equal? Maybe they're not. Figure that out. And then once you have that, then try to solve for x by any means. And then plug it back in. If you need a calculator, I have to look. going to ask for volunteers from one of these back groups here. Sprint groups are kind of volunteers. All right, I'm at least making volunteer. All right, so one of the back groups. What's your initial reaction? What do you think? Any group back there? Okay, what do you got?
12 and 14, together have to 12 and
You're right. Okay, so that's a big thing, right? 12 and 14, they are most definitely different angles. They have to make 180 together. Now, why do you know that? You are correct. Yeah, they're on a straight line. They're called same side interior. She's absolutely right. They're same side. They're in the inside of the picture. They have to make 180. So that's good. So that's what we're going to do here. So let me label that. X plus 51, 3x plus 29. All right, perfect. So we know that they have to add up to be 180. So that's what I'm going to do. So x plus 51, 3x plus 29, and that has to make 180. Okay, so we do that. We do a little bit of math here. So that's 1x plus 3x plus 4x. These add to make, what is that, 8? And now it's just simple math here. So now I've added, I added like terms. Now, moving the 80 across, I'm going to have to subtract it, so that's 100 over here. And if I divide, I get x is a 25. Now, one of the other groups, thank you for that group. One of the other two groups, what am I going to do with the 25? Plug it back in. And I have to plug it back into any one. Really, if you plug it into both, you'll have basically every single angle in this picture. If I plug the 25 in here, 25 plus 51, that would make, what, 76? And if I go to the other one, well, the other one should be 103. That's actually plugging the 25 in here, multiplying it by 3, and then adding 29, or common sense, they have to add it to be 108. And so now that I have that, I have basically I have all the rest of the angles, so alternate interior, vertical, or alternate exterior, whatever you want to do. And now the 104 is for all the other spots. Right? There you go. Now, remember, these are not meant to be like overly challenging, but the problem is like you do need to find all the angles. You don't just find one of them, actually find the rest of them. Okay? The reason why all these work, just like we've been talking the last couple days, the only reason why all these angles are the same, they're all the same numbers, and why you can do this stuff is because it is parallel. That's the main idea, right? That if they're parallel, that's why this works. Okay, we good with the easy ones, I think, like roughly. Seems like you guys got a pretty good handle on this. At least some of you do. All right. Now we need to go to the challenging one. One of the problems that is not easy, but it looks easy. That's one of the weird things. So I'm going to go back a couple slides that I just skipped over. Okay, this picture. It looks easy enough, right? It only wants you to find one angle. That's it. It wants you to find x. That is not an easy problem, which is crazy. It's not easy. Okay? In fact, the only way you can do this problem is by drawing an extra line that isn't even there. So it's what they call an auxiliary line. It's an extra line on the problem that helps you understand what we're doing here. So the auxiliary line that I'm going to put in here is actually a line that goes right through x, like this. And the reason I want to draw that, and it's going to be parallel to the other two, my little parallel arrow. The reason I'm doing that is because once I have this, now I can actually jump these angles around because of like corresponding and stuff. So like this angle here can jump to here because that's corresponding. And this 105 can jump to here because that's corresponding. Okay? The reason why we're doing this is that these are different transversals, so they have different angles, if you can see that. And why that's important is because you need to find these angles here to be able to find these. Because they're different, they're two different angles there. And the reason why I want those is because if I put those two angles together, that makes x. That's the x I'm trying to find. So that's what I need. Now, how would I find this top one? How would I find this thing? Yeah, let's switch around. 180 minus 105, right? And so this would have to be 75. Right? That's what that angle is. Now, the bottom one, same exact idea. Take 180 and you subtract the 25 off, which would be 55. And now that I know those two angles, like by themselves, to find the total for x, you have to put those two angles together. So the 75 and the 55 have to go together, and then makes what, 130? 130? And that's what this angle is. Okay. All right. Questions with how I just did that problem? Like, that is not easy. Like, drawing the extra line in the middle makes no sense to some people because you're literally chopping like the x in half, and it looks weird. But it had to be that way so that we could actually bounce this like 105 round bounce to the 125 round. Okay, so now that I've done that one, I'm going to give you one more, and I want you to try this one by yourself. Okay? So now that you guys get the idea, right? So here's my picture. The goal is to find x now. X is up here. I want to find what this x is. And again, goal is to find x. You will have to draw an auxiliary line on this one. Okay, I'm going to give you a hint where the auxiliary line goes. Okay, all right, go ahead. Let's see if you can figure this out. This is a tough one. If you can figure this out, you are more than capable of doing any of the homework problems. I consider this one to be hard. It's a hard problem. Anyone need more time on that? Okay, so let's talk about it. So I give you a hint where you need to draw your auxiliary line, so I'm going to put that in here. Okay, now what that auxiliary line is doing is it's parallel to the other two lines, right? But what it's actually doing is it's splitting your 72 into two different angles. And why that's important is that will help me find x. Because if I can find this angle here, that'll be the same as this one. That's what I need. I need this little piece here. Whatever, it's a part of the 72. So we know that x is actually smaller than the 72. It's a little piece of it. Because the reason why I know that's a corresponding angle. One's inside, one's outside of the two parallel lines. Okay, but this 50 is important. We needed it. Because what are we going to do with the 50? Yeah, it goes up here. This 50 is a part of the 72. That's this angle here. Because it's a corresponding, it jumps from outside to inside of the parallel lines. Now, why that's important is if this entire angle is 72 and this part is 50, what's left? 22, and that's what x is. Because the 22 and 50 make 72 altogether. So you have to jump the 22 up. It's a weird logic problem. You have to think about, okay, I need to split up the 72 using the auxiliary line because the 50 is going to impact it. It's going to come up here and it's going to break the 72 into two angles. I know that maybe to you it seems easy. Like when you first see it, it's not simple. It's not like the other ones. The other ones are weird because you just jump angles around the picture. But this one's different because you have to like split things up and you use kind of rational thinking about how that works. It's funny. Some people like catch on with that really quick. Some people don't. They just don't like those. Okay, all right. Let's get this one while you're going to do this one. All right, here's your homework right there. This is going to be due on Friday, December 2nd. Okay. Now, let me explain what the homework's going to be. A lot of these, like an abnormal amount of these problems, are basically look at one picture and tell me like what is that one angle. Because they'll say like on problem number, like let's say like problem number 6, it goes, hey, on problem number 6, find the measure of angle 7 on this picture. Oh, okay, so you look at the picture, oh, angle 7 is 100 degrees. So you write that down. Then you go to problem number 8 and goes, okay, look at this picture. What's the measure of angle 14 on this picture? Oh, it's 50. And you write that down. So that's what a lot of these are. It's just looking at one picture giving you what each of the angles are. Okay? And then some of them, there's some in like the middle here, like 19 and 18. They'll ask you, okay, what property did you use? Oh, I did alternate exterior, or I did corresponding. It's one specific reason why it worked. Okay, it's not a bunch. It's one reason on the picture that they're going to give you. Then I think these last couple was some of the ones that like we did today, where I give you a picture and there's like a bunch of missing angles and you have to find them all. But there's only a select few of those. Trust me, the homework is super, super easy compared to what we've just done the last 2 days here. So don't overthink them. Okay, the rest of time is yours, which is about 7-8 minutes, so you can kind of work. It's due Friday. I'll give you some time tomorrow as well to work on it, but tomorrow we're going to definitely move on to session 3-3. Hey, when's this assignment due?
Friday, go ahead.